Today we are going to learn about query execution plans explained. We will discover how to analyze and interpret execution plans to optimize database performance by identifying and fixing slow-running queries.
Welcome to our deep dive into query execution plans. These are critical tools used by database engines to determine the most efficient way to execute a query. For developers and database administrators, DBAs, understanding these plans is crucial for optimizing performance and diagnosing issues. Execution plans are essentially maps that describe how queries are processed by the database engine. They provide insight into the operations carried out, such as scans, seeks, joins, and sorts. Our goal today is to equip you with the knowledge to read and leverage these plans effectively, allowing you to enhance your database's performance.
To start analyzing query execution plans, you first need to know how to access them in your database system. In SQL Server, you can use the SQL Server Management Studio, SSMS, to view both estimated and actual execution plans. The Include Actual Execution Plan option will show you the plan after the query is run. In MySQL, the explain statement is used to obtain execution plans. Similarly, in PostgreSQL, the explain command provides a detailed breakdown of how the query is executed. Execution plans can be graphical or textual. Graphical plans are visual representations, making them easier to understand, while textual plans are more detailed and provide a deeper insight into the execution process. Tools like SQL Sentry Plan Explorer and MySQL Workbench can help visualize these plans. Real-time analysis of execution plans is crucial as it reflects the dynamic nature of database operations, allowing you to see how changes affect performance immediately. Once you have access to execution plans, the next step is identifying costly operations. Each operation within a plan is assigned a cost, typically represented as a percentage of the total cost of the query. This cost is an estimate of the resources needed to perform the operation. Identifying operations with high costs is essential, as they often indicate areas where performance improvements can be made. Common costly operations include full table scans, large sorts, or excessive nested loop joins. The query cost percentage helps prioritize which operations need optimization. Reducing the cost of expensive operations might involve creating new indexes, rewriting queries for better efficiency, or adjusting database configurations. By focusing on these high-cost areas, you can significantly enhance the overall performance of your queries.
A fundamental aspect of query execution plans is the distinction between table scans and index seeks. A table scan occurs when the database engine reads the entire table to find the required data, which can be resource-intensive and slow, especially for large tables. In contrast, an index seek uses an index to quickly locate the desired data, reducing the amount of data scanned and improving performance. Index seeks are generally preferred because they are faster and more efficient. However, table scans may be necessary when no suitable index exists or when working with small tables. To reduce table scans, consider adding appropriate indexes to your tables and ensuring queries are written to take advantage of these indexes. Proper indexing is a crucial aspect of performance optimization, as it enables faster data retrieval and reduces the load on the database engine.
Join operations are a common feature in database queries and execution plans. Understanding how different types of joins affect performance is essential. The three main types of join operations are nested loop joins, hash joins, and merge joins. Nested loop joins are typically used for smaller datasets and involve iterating through each row of one table to find matching rows in another. They can be inefficient for large datasets. Hash joins, on the other hand, use a hash table to match rows and are generally more efficient for larger datasets. Merge joins require both input datasets to be sorted and are fast for large sorted datasets. Each join type has its performance considerations, and the choice of join can significantly impact query performance. Optimizing join operations may involve rewriting queries to use more efficient joins, ensuring that necessary indexes are in place, or even restructuring data to support faster joins. By analyzing join operations in execution plans, you can identify potential bottlenecks and improve query performance. Parameter sniffing is a common issue that can affect query performance. It occurs when a stored procedure or query is compiled using a specific set of parameter values, and the execution plan generated is not optimal for other parameter values. Symptoms of parameter sniffing issues include inconsistent query performance, where the same query runs quickly at times and slowly at others. In execution plans, parameter sniffing can be diagnosed by observing how the plan changes with different parameter values. To resolve parameter sniffing issues, several strategies can be employed. These include using query hints to force specific execution plans, using option recompile to generate new plans for each execution, or modifying queries to make them less sensitive to parameter values. Addressing parameter sniffing is crucial for ensuring consistent query performance across different scenarios.
Execution plans are invaluable tools for improving query design. By analyzing execution plans, you can identify inefficient query patterns that may be causing performance issues. Common patterns to watch out for include unnecessary table scans, costly join operations, or overly complex queries. Once identified, these patterns can be addressed by rewriting queries for better performance. This might involve simplifying queries, using more efficient joins, or ensuring that queries are structured to take advantage of existing indexes. The impact of query design on execution plans is significant, as a well-designed query can lead to more efficient execution plans and improved performance. Execution plans provide ongoing feedback, allowing for continuous improvement of query design. By regularly reviewing and analyzing execution plans, you can ensure that your queries remain optimized and responsive to changing data and workload conditions.
Execution plans often exhibit common patterns that can provide insights into database performance. Recognizing these patterns is crucial for effective performance tuning. Some common patterns include full table scans, index scans, nested loop joins, and hash joins. Each pattern has specific implications for performance. For example, full table scans can indicate a lack of indexing, leading to slower query performance. By identifying these patterns, you can develop strategies to optimize them. This might involve adding indexes, rewriting queries, or adjusting database configurations. Execution plan patterns play a vital role in performance tuning, as they provide a roadmap for identifying and addressing performance bottlenecks. As data and workloads change, execution plans may also change, requiring ongoing monitoring and adaptation. By staying attuned to common execution plan patterns, you can ensure that your database remains optimized for current conditions. As we conclude our exploration of query execution plans, it's important to recognize their critical role in database performance optimization. Execution plans provide a detailed map of how queries are executed, offering insights into potential performance issues and areas for improvement. Key takeaways from today's session include understanding how to access and interpret execution plans, identifying costly operations, and optimizing query design for better performance. Ongoing analysis of execution plans is essential, as it allows you to adapt to changing data and workloads, ensuring consistent and efficient query performance. Continual learning and adaptation are vital, as database environments are dynamic and constantly evolving. By leveraging execution plans effectively, you can enhance your database's performance and maintain a competitive edge in today's data-driven world. Thank you for joining us, and we hope you found this session insightful and informative.